Hello everyone, welcome to part 6 of the probability distribution video series. So in this video we are going to talk about the famous binomial distribution. But if you are new to probability distribution, I would highly recommend to check out my previous video on Bernoulli distribution because it is a prerequisite for you to understand Bernoulli distribution first in order to understand binomial distribution. The link is given in the description. So without further ado, let's dive in. So, binomial distribution is nothing but n independent Bernoulli trials. So what does that mean? First of all, let's talk about independent trial. That means the outcome of one trial does not depend on any other trial. For example, if you are performing 5 coin tosses, the outcome of the first coin toss or the outcome of the second coin toss does not depend on the first coin toss. Similarly, the outcome of the third coin toss does not depend on the first or the second coin toss. That is what independent trial means. So what is Bernoulli trial? Bernoulli trial means the outcome of each trial is either 0 or 1. Actually, here is a mistake. This should be failure and this should be success. So think about 5 independent coin tosses with 2 heads, that means 2 successes, and obviously the rest of the 3 are tails. And also assume that probability of landing coin head is P. So let's see what are the possible cases of this. So number one is we can have 2 consecutive heads and then 3 consecutive tails, and we can basically multiply P, that means probability of success head, into P probability of head into 1 minus P probability of tail, same things twice more. And the answer is P square 1 minus P whole cube. But this is not the only way that we can reach 2 heads and 3 tails. This can be also another combination where the first trial is head, the second trial is tail, third one is head, and then the last 2 are tails. And we can put their probabilities right here, and we are going to reach the same outcome, which is P square into 1 minus P whole cube. Now there are 5C2, that means 10 such possible cases. I haven't listed all of them. Maybe the last one is this one. First 3 are tails and the last 2 are heads, and we are going to get the same probability. So using the law of total probability, the total probability for all these 10 cases is going to be 10 into P square or minus P whole cube. Now I think you already understood how the PDF or probability distribution function, I shouldn't say PDF here because this is a discrete distribution. So I should say rather PMF, probability mass function. You know how it looks like. So it will look something like this. So there are n trials, n cx, x is the number of successes. So for example, here you see 5c2 equal to 10 ncx into p to the power x, x number of success into 1 minus p to the power n minus x. So the rest are failure. So the PMF is very intuitive and simple. So as I mentioned, x is number of success, n is number of trial, and p is the probability of success. So this is how the distribution, the mass function looks like. If you have like 20 trials and if your probability of success is 0.5, as you can see that 20 into 0.5 equal to 10. So our expectation is to get 10 successes and everything is gradually revolving around it. So as we go to more extreme circumstances, the probability decreases. If the probability of success is 0.9, so 20 into 0.9 is actually 18. So we have the highest probability at 18, then gradually it decreases at both parts. And finally, in p equal to 0.1, we see the opposite case. We see the skew towards the left for the probability mass function. If you want to get the CDF or cumulative distribution function, that means probability of x less than equal x. So this x, you can think of it maybe probability of x less than equal 5, right? So what is the probability of getting at most 5 success? So then what are we going to do? We are simply going to write k equal to 0 to 5, and we are going to calculate this probability for all the 5 cases and sum them up. So it is very simple. Now, I think the most interesting part of binomial distribution is the expected value and variance calculation, because we can get them directly from Bernoulli distribution. So as you know that binomial distribution is equivalent to n independent Bernoulli trials, For the Bernoulli trial or Bernoulli distribution, the expected value is P and the variance is P into 1 minus P. This is something we actually derived in the previous tutorial when we talked about Bernoulli distribution. Feel free to check this out. So since this is equivalent to n independent Bernoulli trials, so we can simply multiply these things by n. So expected value will be n into P for the binomial case, and variance will be n into P into 1 minus P for the binomial case. Let's finally give an example from biology of the binomial distribution. So suppose in a particular gene loci or gene location, there are 30 reads, where each read has a mutation probability of 5%. So you can think of these 30 reads as 30 trials and the mutation probability of 5% as success probability of 0.05. So mutation means success. Now obviously mutation is not success, but you can imagine that mutation is equivalent to success and not having mutation is equivalent to failure. So what is the probability of finding 5 mutant reads from this set of 30 reads? If you simply get the PMF of probability of x equal to 5, 5 success, n equal to 30, 30 trials, and p equal to 0.05, success probability of 0.05, then you are going to simply get the probability of this occasion. That is all about the binomial distribution. If you like the video, feel free to subscribe and share. And there is a donation link in the description. If you like the video, you can donate to our channel for contributing to our contents. Thank you very much.